Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how you can determine what the uncertainty is of a given value or given measurement if the measurement is all that they give you, and in addition to that, determine what the highest and lowest value of that measurement is. But before we get into this, please remember to subscribe to my channel, like this video, share this video, put a comment in the comment section if you like the video, and let me know what you think. Okay, with that out of the way, let's get into this. So here we have a question. Given the following values, what are the derived? What are that are derived from measured units? So that's important. They're derived from measurements. What do you assume is the range of possible values that each represents? So in order to figure out what the range is the highest and lowest values. So anything within the highest and lowest values would be allowed for that measurement. And so in order to figure out what the highest and lowest values are, we need to know what the uncertainty of these measurements are. So unless you're told otherwise, the rule of thumb is that the uncertainty is always in the last digit. So plus or minus 1. Okay. So that is, unless you're told otherwise by the instrument or by the manufacturer what the uncertainty is, you assume it's a plus or minus 1 in the last digit. So since we're not really given any information about these from the manufacturer, then we assume it's plus or minus 1 in the last digit. And so remember, uncertainty is that wiggle room in the measurement device. So also in the way in which the observer, the person who's doing the measurement, reads the instrument. And so depending on the instrument, that uncertainty can be different. Okay, so so here we're given a 636 grams. No other information. This is a measurement, so it must be plus or minus in the last digit. Since the last digit is here, then it's plus or minus 1 in that digit. So it would be plus or minus 1 in the ones place. Since the last digit is in the ones place, then it's going to be plus or minus just 1. So this is our uncertainty. This is our fluctuation in the measurements that we can get using whatever tool they used. Okay, so now the question is, what's the range? What's the highest value? What's the lowest value? And that's easy once you understand what the uncertainty is, because the uncertainty tells you what the highest and lowest value is. It's plus 1 or minus 1 in that last digit. So if I add 1 to the last digit, that would be the highest value in the range. So if I add 1 to this, that would be 637 grams. That would be the highest value. If I subtract 1 from this, then it would be 635 grams. And so that's the range. Anything within this range is acceptable using the tool that we used. Anything that falls outside this range would not be acceptable. Some sort of mistake was made, it would have to be thrown out. So it would, any value that is less than 635 or greater than 637, that would be outside the margin of error. So this would be inside the margin of error given our uncertainty. Okay, so that's how you figure out the uncertainty, and that's how you figure out the range. So that's easy for numbers that aren't in scientific notation. So, but what if you have numbers that are in scientific notation, really large numbers or really small numbers? What do we do then? Well, we figure it out the same way. However, we got to be careful about where the last digit is located. So it's very easy to see what the last digit in these numbers are. So let's look at B. So the last digit is 2. So we know that the uncertainty for this digit has to be plus or minus 1 in that last digit. But where is that last digit? What place is it in? If we're not careful, it looks like it's in the 10th place. but it's not in the tenths place because remember, in order to go from your normal number, your standard number, to scientific notation, you had to move the decimal point. So that decimal point really isn't there in the number itself. We only put it there because we're writing this in a different format. It's in this scientific notation format. So even though it looks like it's in the tenth place, it's not. We have to move the decimal point back. So two ways of doing this. You can move the decimal point back to where it originally was, right? So one way would be to move this back to the place back. So since we know this is a positive number, we know therefore it's got to be a large number. So since we know it's a large number, we got to move it in this direction to make the number large. And so our exponent tells us how many times we move it. So we got to move it over 9 times to the right because we want to make the number a big number. So if we move it over 1, that's over here, and then 8 more times, that's going to be 8 zeros. So that's going to be 52000. That's 0006, and then we got 2 more. So that would be this number there. So that 2 is obviously in this place, so it's plus or minus that place. So that place is in the millions, the 100 millions place. So it's plus or minus 100 million, right? And so it's going to be, the highest number is going to be plus that. So it's 53. Oops, I forgot there. So it's going to be 5,300,000,000, and this is 5,200,000,000. So this would be the highest value, and this would be the lowest value by subtracting 1 from there. So it would be 5 and 100,000,000, right? So that's one way you can do it. You can just write it back into its normal form. But for numbers that are really small or really big, that's kind of inconvenient. So there's got to be another way to do this. And there's an easier way to do this. So another way to do this would just remember, well, I want to know what place this is in. So all you need to do is move the decimal back to the right of the last digit, since you want to know what place that is in, and then you could write the uncertainty in scientific notation. So if I move this over 1, right, and keeping in mind, if I move it over 1 this way, I'm making this bigger, so I got to make this smaller by a factor of 10. So if I'm moving it back this way, then I got to reduce and make this more negative or less positive. Because the reason is because I had to move it this way to make the exponent positive. So this means the 10 to the 9 means I moved it over 9 times this way. So if I'm moving it back this way, then I got to reduce this number by that number of times that I move it. So I'm moving this over once, and so now I reduce that by 8. So that means that the 2 is going to be in the times 10 to the 8th power. So that's the place. So if I put a 1 there, so 1 times 10 to the 8th is the same as plus or minus 1 of these, 100 million, right? So the uncertainty for this, according to this, is plus or minus 100 million. That is the uncertainty based on this, that when we wrote out the number in its normal form. So that's one way to do it. The other way to do it is to just move the decimal over to the right of the last number, the number of times you had to move that over, you're going to reduce the exponent by that number. Or a better way to say it is you're going to make it less positive or you're going to make it more negative. So since this is a positive number, I'm reducing it to make it less positive. So then I moved over one time, so that brought that down from a 9 to an 8. So that would be the same as plus or minus 1 times 10 to the 8th power, which is exactly what we have here. So now that we know what now that we know what the uncertainty of this number is, we can now figure out what the highest value and lowest value based on here. So if I keep this in scientific notation, all I need to do is add or subtract 1 from the digit. That's it. So if I add 1 to the digit, then the greatest number becomes 5.3 times 10 to the 9. So I keep the exponent the same. I only change the exponent to get the plus or minus uncertainty. If I'm trying to find the lowest and highest value, I keep everything exactly the same for the number. All I'm doing is I'm changing the last digit. I'm either raising it by 1 or lowering it by 1. So when I get the lowest value, it's going to be 5.1 times 10 to the 9th power. And that's it. That's how you would do that problem. Okay, let's apply the same reasoning here. Let's just do it the short way using the scientific notation. So I want to move the decimal point over to the last digit. So our last digit is here. I want to move the decimal point over to the right of that last digit. And the number of times I move it over is the number of times I'm going to reduce the power. I'm going to make this more negative. It's already negative, so I'm going to make it more negative, right? So let's see. I'm going to move this over 1, 2, 3, 4. So I moved it over 4 times to the right. So that means I'm going to make this more negative. So it's going to be plus or minus 1. It's always plus or minus 1. And then since I moved this over 4 times, I'm going to have to make this more negative by 4. So that's going to be negative, if I add 4 to this, so negative 4 minus or negative 27 plus another negative 4, that's going to be what? That's going to be negative 31. So 27 plus 4 gives me a 31. That's negative. So it's plus or minus, So it's plus or minus 1 times 10 to the negative 31 power. So this is my uncertainty. That's my fluctuation. Now, what's the highest and lowest value? Well, I take the original number that they gave me in scientific notation, and all I do is I add or subtract 1 from this digit. So if I add 1, then the highest value would be 6.5291 times 10, and I keep the coefficient. I keep the number the same, the exponent the same. So this is going to be negative 27. And then for the lowest number, I subtract 1. So that would be 6.5290 times 10 to the negative 27. So this would be the highest expected value. This would be the lowest expected value. And so that's how you do it with scientific notation. So you don't have to rewrite the number out in the standard form for really small numbers or really big numbers. That would be too cumbersome. You can keep it in scientific notation and just move the decimal point over to the right of the last digit and then subtract from your exponent that number from your exponent. I hope this was helpful. I hope that made sense. If you like this video, hit the like button over here. Make sure you share it with others. Put a comment in the comment section. Subscribe to my video. Give me some help. And thanks for joining me. Have a nice day.